If you have any doubts or queries, you can put it in the comment box. So now over to you. I invite Aslam Ubaid for the session.
കണക്റ്റായി ആയില്ലേ? ഓക്കെ. എടാ, കാണുന്നുണ്ടോ? ഓക്കെ. ക്ലിയർ അല്ല? ഓക്കെ, താങ്ക്സ്. Hello, good evening. I'm the inconveniences caused. The network issues that caused a delay. Uh, I guess I'm audible, right? Thanks. Thank you, Sneha. Well, thank you, RSSBNSC, for inviting me to talk about my project, ProBion, which stands for a prosthetic bionic automated device. Could be implemented in many different ways. I guess we can just jump right straight into it. While discussing about a project, the main things that we have to look into are what, why, and how. We will have many crazy ideas to begin with. We will begin by creating some rough sketches, rough ideas, and then we will proceed to make before getting right is why. Why are we doing this? What are we trying to achieve? Or who are we trying to provide this to? These are some questions that we should ask before we should begin the how. How is the stage where we will decide how the project should go, what all should be done, begin it in order to get it working, in order to build the whole thing from the ground up. Well, I guess before talking about all that, I should address some of the had done before. One OpenCV project, I assisted one of my seniors. It was his final project. I had assisted him when I was in my first year. It's a machine learning program that when an image of a KVL or KCL circuit is given, it will solve it for us. That was one of my first projects. Then came Ayuda, which was a project which was an unmanned soldier assistance vehicle, which was presented DRDO's Druze competition, and we win the national championship, uh, sum of 1.5 lakhs. Well, what about we talk about what is what is the neural signal interpreted bionic prosthetic automation device? Well, in simple words, it is just like any other prosthetic device, but which will enable people to do about their life freely, like they would do a normal way. We happen to uh, we happen to present this project at the Regional Science Center in Calicut, and we happen to win the first prize there. And the idea came to me when I happened to see a lot of cruel wars and governments that cause people to lose their limbs, and people who are either paraplegic or quadriplegic who wish they could walk or they could do the stuff we normally do in our daily lives. This was what with ProBion is a device and a robotic device which will mimic normal human body movement that will enable us to do about with our life normally. The device is merely a simple device, but the everything which comes behind it is what it makes it special. We were planning to take EMG data, that means the electromyogram data, which are the electric impulses that goes through which enable us to move our joints, our muscles, and that is what enables us to move or enables us to do whatever we do on a daily basis. Well, first challenge, taking EMG signals isn't so easy as we think it is. When we take the EMG from a joint or from a muscle, what we get is a cumulative total of all the muscle that are happening there, and which is uh, not that great training model or training data to be precise. So we wanted to make a precise, a more concise way to harvest these EMG signals, and we have know more about reinforcement learning, which is a type of learning algorithm. And what then were we created a system. We created for sensing the muscle and taking the EMG signals overall and correlating both with each other. It takes tens of thousands of training data to be able to make it precise. But what we learned was each is different, and person contributes to different types of signals, or the average would be the same. But what happens is one data which is harvested person could not be used for the other in the similar way that he used it. And when that dilemma was faced, we happened to for friends who were experts in machine learning, and we came up with a different program, and we were able to it. We didn't do the whole thing. We did complete the training process, or we didn't even start the training process. We one of the first thing that we faced were we did were 3D print a prosthetic arm in a simple way. Well, let's discuss the why. Why do we do these kind of projects? Why do we do projects basically? Well, we might see some needs in the world, and we have a tendency to make it right? So, when I came to know about a few people who were in desperate need of a normal life, the normal life that we lead daily, that's when we did it. And we kind of have discussed the how, why, and this is what we are trying to tackle. We have about joints in our human body, and what we are trying to augment is the same movement that each of our body exhibits on a daily basis, but in a more elegant and more humane way. Well, it is by itself indeed a great challenge. We have to mimic each and every complex movement in our body so as to make it function properly as we intended to, but which is not that possible as we might have known. Many people in reputed institutions like MIT, Stanford, Harvard, etc., have tried, and they are still working on these kind of projects, and we are seeing advancements in this field on a daily basis. This was one of the first designs, kind of, this is not exact design, this is mostly one of the designs that we came up with in our initial stage, which one of our seniors did. uh, they used a few servo motors to control each fingers using a string, which is great. We could mimic the finger movements in a precise fashion, but when it comes to bearing heavy loads or even doing basic actions, the control.
Eta, excuse me.
Yeah, please.
Yeah, we couldn't see your presentation.
Pardon.
We couldn't see your presentation. Like, the screen is not sharing, I think. Can you please look into?
Okay, let me check. Is it visible now?
Just a minute. Now it's visible.
Okay, yeah, thanks. Yep. So I was saying that these were one of the initial designs that we came up with, and we happen to present it at many places. But as you can see, this is a flimsy design by itself. This was a 3D printed design that we made in our Fab Lab, and what happened was the device would malfunction, or it would fail at certain points, which were unpredictable by itself. And the overall movement that we tried to augment was not achieved by this. So we came up with a different design, which needed BLDC motors on each joint. But the problem which we faced then was that uh, such a small motor with high the torque that we required were not available. So we tried to do with what normal robotic arms, the arms that we see in a automobile manufacturing company, etc., would do, and we tried to augment it. And to my surprise, it didn't work as well. So we came up with many different designs and many different ideas to tackle it, and we are currently proud to say that we made a design that we could augment these movements completely. But the main problem that we face is funding, and as you all know, big projects like these require so much funding, and that's where we are right now. Let me talk about the whole thing, whole technology that we use to harvest the muscle movements and EMG signals. Well, you can see here there is a gloves that we wear on our arms. When we move our fingers or even any of our joints in our arms, there are some flex sensors that are placed on each joint. So when we move a muscle or move a joint, what happens is that that flex sensor flexes and which produce an electric signal. At the same time, an EMG sensor will sense the EMG signal that is responsible for that precise movement, and we correlate both these signals, and that's how we train our model. We need tens of thousands of training models or training data to be able to automate it fully. This is the whole thing. Well, there are four main components: the DMAT, the NSRI, the FRA, and the BPA, which are funny acronyms that I myself gave. So we acquire the volunteer test data, and these volunteer test data consist of EMG and muscle activities recorded. Then these data is fed into our neural signal a reception and interpretation device, which could be a Raspberry Pi computer, which now is more powerful than what we have seen before. We have huge processing capabilities in there, and we could use that device, that pocketable device, to control this whole thing. This neural signal is then fed into the onboard signal processor and interpreter, which could be a Raspberry Pi computer, and these signals are then given into the command splicer, which is also another computer or the same computer. It could be the same computer, and which is fed into the prosthetic device, and there is a feedback loop involved. When we touch something or we grab something, uh, the torque that we apply will cause a reaction, right? And this backward force is measured, and that's how the feedback loop works. And this is not just limited to an arm. This device could be implemented into a prosthetic leg or a prosthetic spine even. That was the big idea, to be able to make people walk from their beds. Like people, many people who are quadriplegic are confined to their beds and they couldn't even move. That's one of our main focuses. And if we could implement it in a whole new level, we could even make exoskeletons, which might sound futuristic and stupid, but still, these exoskeletons could be implemented in many various types of scenarios, in manual labor situations where people could impact from this, and they could benefit from this, and they could do much more than what a normal person could do. Then comes the military use. Well, these training data which we acquired could be fed into a humanoid robot, which could be deployed in several many places where uh, where it is needed, and we could use these potentials to evade threat, to do whatever is necessary to keep peace. This could be used for surveillance, where human life is invaluable. You all agree with that, I believe. So instead of sending human beings to potentially dangerous places, we could send humanoid robots with human capabilities, or a remote controlled humanoid robot with similarly human capabilities, and we could benefit from these things, like if there is a bomb which is placed somewhere, or if there is a forest fire, or if there is some sort of danger, imminent danger, that we could avoid or that we could evade, we could use these things. These were the big ideas or the hopes that we had when we were designing this thing, and we happened to talk to many experts working in the similar field. There were Open Prosthesis and Prosthesia, which is a startup based in Massachusetts Institute of Technology, and we discussed with one of its founders, Mr. Guillermo, and we got many ideas from him, and we were trying to implement a whole new system for it, and we are still on the process of doing it. So I guess the parts which were built were the device to harvest uh, the EMG signals and muscle movements, as well as the 3D printed arm. And to an extent, which were really successful, but not to an extent which we would prefer it to be. That is the whole story of ProBion. I hope uh, you got a good idea about what it was and what it is right now. That's it. I hope you might have some questions. I'm happy to answer those.
If you have any queries, please do comment in the comment box.
I guess there are no more questions. Well, I would like to discuss a few more things uh, regarding doing these kind of projects. The main thing is we might encounter many problems, many challenges, many hurdles while dealing with these type of projects, and most of those hurdles could be tackled in many ways. We could ask for external help. We could ask people who have experience in these fields. We could ask even people working in different spectrums or different fields who could help us. Well, use these situations or use these help that are available to us, even free of cost, so that we could impact the society in a greater way. Also, we have IEEE, which is an international organization with huge potential and huge resources within it. And using those resources are likely to be more in potential than what we could occur from outside. Yeah, that's it. That's mostly it.
Yeah, so let's conclude. I think we don't have any queries.
Yeah, fine, fine, fine. It's all right.
So on behalf of IEEE RAS, I thank Aslam Ubaid for being with us today. All the best for your future. Always do come up with such innovative projects. And once again, a very happy birthday to you.
Thank
Thank
you.
you,
Thank
Atam.
you. Thank you
And
for
thank you
inviting
all.
me. And I hope the inconveniences caused were not that big. I am extremely sorry for uh, that.
That's okay,
But
Atam. That's okay.
yeah, and thank you for
Okay.
inviting me. Thank you, NSSE, again, once again for that you have done for me. Thanks.
Thank you all for joining us. Do fill the feedback form provided in the comment box. Once again, thank you.